In this final section, we're going to learn how to solve when there's more than one variable term. So let's review this information. In all of the equations we've solved thus far, there is only one variable term in the equation. Since this was the case, we could create the construction based on the only variable. So for example, try to think of the construction process for x in the equation below. So looking at this equation, notice there's three terms with x in them. First, we need to multiply this. We have a 2x here. Then we have the sum of x and 2 in parentheses. And then we even have an x on the other side of the equation. So currently, we don't know how to solve this equation using our process. We couldn't create the construction story for x because there's not a single x to start with. Okay. So in this section, we will learn to use combining like terms and/or the distributive property to create an equivalent equation that we can solve. In general, we will use the distributive property whenever appropriate, combine any like terms, and then use the addition and multiplication properties of equality to ensure there's only one variable term. Then we'll solve as we did before. So let's just sketch an outline. So our immediate goal is to have one variable term in our equation. And here's how we're going to achieve this goal and in what order. So first we're going to distribute if this is necessary. So for example, in the equation above, we'd want to distribute the 3 to x plus 2 first. So that way we can combine like terms. Right now the x is trapped in there. We can't combine like terms to combine this x with any other term. And then we will combine like terms. Okay, so we practiced both of these skills in the previous unit. Then we're going to use the addition and multiplication properties of equality. To ensure there is only one variable term, but to create one variable term. And then our last step is to solve as we did before, using the construction and deconstruction process. And we're also going to connect this idea of how we constructed and deconstructed to using the addition and multiplication properties of equality. So let's remind ourselves what that is. So here is our slide with this information, and this is in your media lesson packet from the second or third video. The addition property of equality states, if two expressions have the same value and you add the same quantity to both expressions, then the resulting equation remains true. Note, we may consider subtraction as adding the opposite. So let's look at a picture of this. Here's our balance scale. If we know that, say, x equals 2, we could have our scale balanced with x on one side and 2 on the other. Okay. The addition property of equality states that we could now add any number to both sides of the equation. So I'm going to add 5 to both sides of the equation, and the equation is still true. So we did this when we built construction webs. So we started with x equals 2. Now we changed it to x plus 5 equals 2 plus 5, which is 7. Notice they're different equations, but they're equivalent equations because they have the same solution, namely 2. Okay. This also applies to subtraction because we can think of subtraction as adding the opposite. We don't need to, but we could think of adding a -3. Let's make this a balloon that floats. Okay, so this is a bit of a stretch, but you could think of taking 3 away or adding a -3 removes 3 from both sides, so it's still balanced. Okay. As far as the multiplication property of equality, it states that if two expressions have the same value and you multiply both expressions by the same quantity, then the resulting equation remains true. Note we can consider division as multiplying by the reciprocal of the divisor. So now we also know that we can multiply or divide both sides of an equation by the same value and it's still true. Okay? And a nice way to think of this, let's make another scale. If we started with, let's do, how about x and 3 this time? Okay. Well, we can multiply, so x equals 3. We multiply both sides by 2. We have 2 times x, or 2x, equals 3 times 2, which is 6. Okay. Or you can think of this as an extension of this addition property. Well, we can add an x to the left side and a 3 to the right side. Okay. And we know x equals 3 because it was originally balanced. And notice now the left-hand side has 2 x's, the right-hand side has 2 3's, and the equation is still balanced. So these are the properties of equality we're going to use to help us get a single variable. So let's try these first two problems. Rewrite the following equations as equivalent equations with only one variable term, then solve for the variable. So let's look at part A. Now notice on the left-hand side we have two variable terms. We have 4x and negative 2x or minus 2x. Okay. So since they're both on the same side of the equation, we can combine these. Okay, so think of this as a separate expression. This expression equals the expression negative 3. We can combine on the left-hand side like we learned before. And just to remind you, this is how we did that. We'd say 4 minus 2 times x plus 7 equals negative 3. So this was the reverse of the distributive property. 4 minus 2 is 2, so we have 2x plus 7 equals negative 3. Okay, so we combine like terms. We didn't need to distribute here. And when we combine like terms, we now have only one term with an x in it. So now let's write our construct and deconstruct process, and then I want to show you how this works with those two principles of equalities. So we're going to shorten it a little bit. Instead of writing out all the language, which is important, but we've done that a lot now, we would take x, we multiply it by 2 times 2, and add 7. The result is negative 3. I'll put equals negative 3. Now if we were to reverse this, we would start with negative 3, subtract 7, divide by 2, and the result equals x. Okay. So we can work through this process. Okay. So negative 3, subtract 7, divide the result by 2, and this equals x, which gives us negative 10 over 2, or negative 5. Okay. But let's look at how we can use the principles of equality on this expression and how it corresponds. Okay. So remember, our goal is to get x by itself. We want to know what x equals, and that's why we performed this deconstruction process. So first, we don't want to divide by 2 first. We could divide both equations by 2, but it would give us fractions. So why don't we subtract 7? So if x is x times 2 plus 7, you want to do the last operation you would do on the left-hand side, which is subtracting 7. So I am allowed to subtract 7 from both sides of the equation to create an equivalent equation that will have the same solution. This is 2x plus 7 minus 7 is 0, and this is negative 10. Okay. So we usually don't write the 0, so we have 2x equals negative 10. Now this should look familiar. So here we had the negative 3 and we subtracted 7. Okay. And now the next step, well, we have 2x, we want to know what 1x is. So this is 2 times x. To reverse multiplying by 2, you can divide by 2. And I'll divide both sides of the equation by 2. 2 divided by 2 is 1x. Negative 10 divided by 2 is negative 5. And we get the result of x equals negative 5. Now notice how this applied to our deconstruction process. Okay. We had the negative 10 from the negative 3 minus 7. Then we divided by 2, and our result gave us x, which is negative 5. Okay. Let's look at the next one. Okay. So here, notice there are 2 terms with x in it, and we're going to need to start by distributing. So we're going to multiply here and here. So we have 3 times 2x minus 3 times 2 plus 3x equals 12. Notice I'm writing down the whole equation. Don't skip anything and save it for later. If you want to do this multiplication on the side, that's fine, but here you're going to write the whole equation. Now let's multiply. 3 times 2 is 6, so this is 6x minus 6 plus 3x equals 12. So we've used the distributive property. In this case we needed to, whereas here we did not. Now we're going to combine like terms where we can. So we have a 6x and a 3x on the left. Okay, there's no other constants on the left, so that's all I can combine. And 6x plus 3x, we could use the long-term distributive property, but let's just start using the fact that we can add the coefficients. 6 plus 3 is 9x minus 6 equals 12. Okay. So now we have one variable. Okay. So we can use our construct and deconstruct process. So let's write it out. Here we would take x, start with x, multiply by 9, and then subtract 6. Our result would be 12. To reverse this process, we would start with 12, we would add 6, divide by 9, and our result would equal x. So 12 plus 6, all divided by 9, equals x. This is 18 over 9. When I add, then 18 divided by 9 is 2. So we get a result of 2 using construction and deconstruction. Now let's use the principles of equality to connect these ideas. Okay. So first, again, we have 9 times x minus 6. We're going to add the 6 first. Okay. We divide by 9. We're allowed to, but notice how that would make things messy. We'd have fractions, and it also doesn't align as well with this process. So first we add x to both sides, or add 6 to both sides, and our equivalent equation is 9x minus 6 plus 6 is 0. I'm just going to leave that out now. Last time we wrote it, but just know that that cancels, or cancels to 0. And 12 plus 6 is 18. Okay. Now notice on the right hand side, here's our 12 plus 6. Okay. Now our next step, we have 9 times x. To undo multiplying by 9, we would divide by 9. So we can get 1x. 9 divided by 9 is 1. We could write 1x, but generally we just know it simplifies to x. And 18 divided by 9 is 2. Okay. So there's our 18 divided by 9, and it corresponds with our construction process. In the next video, we'll do 2 or 3 more problems.